process of how you do an entity and how you do a relationship in the ER diagram. So let's do an in-class exercise. I want you to read the following and draw an ER diagram that would go with this description. Right? So please feel free to work with the people around you as well. Just raise your hand if you have any questions, and I and Kate can come and help you guys as well. You don't need to hand this in, but do write it down. Guys, can you read this at the back? To pick it up?
How many numbers?
Guys, I'm just going to run the clicker here. Whenever you're done, just click so I know how many of you have finished. just.
But simple number of aspects, depending on how long. So,
So then in terms of
okay, for this course, just so yeah.
Another problem is
I mean, I guess the way I can visualize it is if this is its own table with 3 columns, like course ID, I didn't actually have like any what do you guys think?
Yeah, I think so. I think so.
How would you like to take out one of them?
Oh, really?
The department says
maybe there can
Right, whenever you have your diagram, answer the following clicker question. time to work on the diagram? Right, 5 seconds. 4, 3, 2, 1. End of clicking. Okay, so C seems to be the right answer. Let's check it out. Okay, so let's look at the description again. We want to have courses, and those courses are going to have a title maybe, and also the number which is specified to the course is coming from the department. That means the number of the course on its own cannot be the key. You also need to have department as part of that key as well. So a course is going to be unique within one department, but it's not the case that the courses generally have unique numbers. One thing that I was walking around and I noticed is that there's a standard on what shape to use for each of these. Right? So an entity is always going to be a rectangle. Attributes are going to be ovals. Keys are going to be underlined. And if you look at my previous slides, diamonds are going to be relationships. Okay, so my apologies for not mentioning that before. Diamonds are going to be relationships. We have entities. Two entities are not related to each other without a relationship. So you cannot have two entities just being connected with a line. Also, lines cannot have value. So if you want to add something, that needs to be added as an attribute, like roll here. So if you have movie people and movies, and there's an attribute, you can't put that on the line here, but rather you need to have a relationship, and that be an attribute inside your relationship. Okay, so let's go back to here. So we have course. Course has department and number. We also have students. Students have ID and name. And we've been told that ID is what makes them unique. So students have an ID, which is making them unique. And then we have enrollment, where enrollment is now going to be associating courses with students. And there's a grade that I'm going to keep for that enrollment. Okay, so let's look at the different values that we had here. A saying entity set students with attribute ID not underlined. It is underlined. Entity set student with attribute ID and name underlined. No, name is not underlined. C is the correct answer. D, entity set courses with attribute department underlined and attribute number and title not underlined. Number is also underlined, and none of the above is not correct because C is the right answer. Question?
Why would you not consider term as primary, so like key for the course?
So the question is, your name?
Key.
T. The question is, why don't we have term as part of the enrollment? Is that right? Or where do you want it? As course?
Key for the course.
Term for the course? You want to store term as an attribute for course?
I feel that's necessary for course to be unique.
Yeah. So you can have term as well. I'm going to have another example soon, which is shows you that we have courses, and then what you might take is an offering of a course. So we'll have an offering which was going to have that term as well. But something that you're right about is that currently there's something wrong with the current ER diagram that we have. What's going to happen if you want to take the same course twice? Can you do that in this ER diagram? We're going to talk about why you can't in a minute, but because the key is going to be department, number, and student ID, that means the key is only allowing you to take this course once. Unfortunately, if you fail the course, you're doomed. You can't get your bachelor here anymore. So there's something wrong with this, obviously. And this is where the term could come in place, that if I have term in as well, then I can have that term as part of the key, and then I can have 2 grades for the same course. Any other questions? Okay, so that worked pretty well. But what if we wanted to add instructors to courses and restrict that each course could only have 1 instructor? With what you know so far, there's no way that we can make any restrictions on how many times a student is taking a course and how many people are going to take, how many students take a course. There's no way that you can restrict that. If you want to make a restriction on the fact that there's only 1 instructor for the course, we need to look at more how we can do that. Cardinalities. We can have 4 different types of cardinalities. We can have one-to-one from A to B, which means that you have a set of values as A, you have a set for B. And when it's one-to-one, it means that any value from A can only be associated with 1 value from B. It doesn't say that every value has to participate on either A or B. But what it's saying is that if it's participating in that relationship, it can only be associated with 1 value on the other side. A good example of this is drivers as A and driver license as B. Okay, so not everybody has a driver license, but if you have one, you're restricted to 1, at least within BC. That's it. You also have one-to-many from A to B, which means that any entity from A can be associated with multiple values of B, but B's can only be associated with 1 value from A. Okay, so an example of this could be A as biological mother and B as children. A mother could have multiple children, but each person is only going to have 1 biological mother. Or manager and employee, which doesn't always have to be true. You can have multiple managers and employees. So this is a better example. And many-to-one is just going to be reversing A and B. So many-to-one means that your A can only be 1, but your B could be associated with multiple values of A. And finally, many-to-many from A to B means that you can have 0, you can have 1, or you can have multiple associations on either side of A and B. Basically, there are no restrictions whatsoever. Any questions about the cardinalities? Okay, so key constraints. The restriction imposed by a one-to-one or one-to-many ratio are examples of a key constraint. I'm adding a constraint on my ER diagram. Now, if I want to make a one-to-many constraint, what I'm going to do is I'm going to add an arrow on the side that has a many. So if I have movie people and I have a relationship direct, which is going to show me the director for that movie, that means that there's only 1 director for this for each movie, and I can't have multiple directors. Okay, so this arrow here is indicating that there's going to be 1 movie person, which is going to be the director per movie. If you want to have a one-to-one relationship, then if I have an arrow on this side, that means the other side is 1. I also have an arrow on this side, that means the other side is 1. So both arrows would mean that I would have a one-to-one constraint on my ER diagram. So let's have a look at an example. So, movie, direct movie people. James Cameron is a movie people, Avatar is a movie, and there's only 1 director for the movie Avatar. If you want a way to remember which way to put the arrow, because I know it gets confusing, is that think about once you know the movie, so let's say once we know Avatar, you can point to the director, because there's only one of them. So if you see that arrow as pointing towards the specific value on the other side, that might be a way for you to remember which way to put the point. So once you know the movie, you point to the director, and that's how this works. Any questions? How can we uniquely identify a relationship? So previously, we talked about an entity and making sure that there is a key for each entity. And we discussed why that's important. But once we have a relationship in place, it's also important for us to have a key for that relationship. And if you have a relationship that's between two different entities, we want to see how we can find what that key is. Can anyone guess what the key here would be? Yeah. What would it be? Role? So, let's recall what we're going to mean by the key here. So a key is going to be something which is going to uniquely identify a person and a movie and their role for me. So let's say if I know only the actor, that's not enough for me to know the relationship. If I know just the movie, that's not enough for me to know the relationship. But if I know both the actor and the movie, then I can determine the person and also the role inside that movie. So for work on here, the key for the work on relationship is going to be the movie people ID plus the movie ID. Does that make sense? Question?
Well, then you need the role as well, because only saying his name in the movie is not enough to say what his role is in the movie. So when do you need the role as well?
That's a great question. So let me rephrase that. What's your name?
Jackson.
Jazz?
Jackson.
Jackson. So the question is, should role be also part of the key or not? Because without the role, we might not be able to find the right ER model, the right key. And I'll rephrase that with what is the current limitation if we keep the ID and ID as the key for this relationship? Because it's going to come with a limitation.
Different people may have worked in the same movie.
You cannot have different people working on the same movie.
Can one person act as a have
Not with this one. With the current way that we have this, if my key is going to be movie people ID and the movie ID, I cannot have the same person having multiple roles in the same movie. An example of this would be Prestige, where Christian Bale was playing the role of both brothers. You can't have that in this relationship. Because the same person is now having two roles, and the key is not going to allow you to do that. So if I have a many-to-many relationship, so it's many-to-many, to find the key for here, it's going to be the key of this entity, plus the key of this entity, plus possibly attributes from the relationship. The combination of the three are going to be distinguishing the right key for your relationship. Any questions? Question?
How do we show a key constraint in a relationship with more than two entities?
How can we show the key in a relationship with more than two entities?
Key constraint, like one to many, if there's three
It
entities.
gets confusing. So the question is, if we have three entities, how can we show a one to many to one or many to many to many? We're going to talk about aggregation later in this chapter. Good question. I have your name?
Alex.
Alex? Good. Any other questions? Okay, so if it's a many-to-many relationship, then it's from both sides we need to take the key. How can we uniquely identify a relationship if it's a one-to-many relationship? So if I have a one-to-many relationship, would it be enough if I take the idea of the movie person as the key for direct? It will not be enough, because once I know James Cameron, I can't uniquely identify the relationship direct, because there are multiple movies that he has directed. If I know the movie, would that be enough for me to uniquely identify the director? That would be enough. So in a one-to-many relationship, we only need to take the key from the entity with the many part on in order to find the key. Alright, so previously we needed key from both sides. In one-to-many we needed just from this side. What about one-to-one? If I have a one-to-one relationship, what would be the key for that relationship? Anyone want to guess?
Either or, either idea of country or idea of...
That's good. So if you know the country, you can find the capital. If you know the capital, you can now you know the country. So either one would be enough for you to determine what the key is. Again, with a primary key, you can only have one primary key. So although it could be either or, but at the beginning, when you're designing this database, you're going to take one of these as your key, and then you're going to stick to that. So here's a summary of primary keys and relationship sets. So if it's a one-to-one, it's going to be either or. If it's a one-to-many, it's going to be on one side. And if it's a many-to-many, you need keys from both sides. Any questions? That means I click your question. Alright, so try this one on your own first, please.
So where does E and F come? When so the A1 and A2 are only A's. So there's only A's and only Q's.
Right.
So you just say like there's an E1.
Oh, so that's just an example. So if you have a T with E1 and F1, that means there's a relationship between E1 and F1. So there's no actually E1 and F1. It's just an explanation of what that notation is. Let's finish the first round and then I'll get you to discuss it with your neighbors. Let's finish it in 5, 4, 3, 2, 1. Okay, so this is where we're at. Right, discuss it with your neighbors. Alright, let's finish this in 5, 4, 3, 2, 1. Okay, so some of you were able to convince your peers that B is the right answer. Let's have a look together. So, clicker participation, I'm not going to count today. We're going to start the participation starting next, Wednesday. So if you don't have it today with you, don't worry about it. Okay, so let's see. The diagram says that we have entity A, and entity A is into a one-to-many relationship with B. So the arrow is saying once you know A determines B, right? So A is pointing to B. So for the same A, you can't have multiple B's.
With the same B, you can have multiple A's.
So once you know A tells you what B is, right? Once you know A, you can point to B and say that's the value for B. So let's see here. So for example, here, and also the same, once you know B determines C. Right? So why is the first one not correct? Because once you know B, you should know C because B is determining C. But here we have B2 in association with C1 and also B2 in association with C2. which is a restriction and you cannot have that. Let's look at C. C again says that you have B2. Once you know B, you should know C. There's different C's here. And let's look at A. A says that once you know A, you should know B. So once you know A2, you can have multiple values for B. So you can have both A2B1 and A2B2. Having A1B2 and A2B1, just the two of them on their own would have been fine. So the only two remaining values is it B or is it none of the above? Let's look at B. R doesn't have anything, so with the restriction that we currently know, which says that there should at most be one A for B, there's nothing wrong with that. And this part is saying B1 is associated with C2 and B2 is associated with C2, which is fine, so B is the correct answer. Does anyone have any questions? Question?
What does that mean? I didn't catch that. When you have empty brackets.
So that means you have a relationship. Let's say you have a course that no one has taken yet. So if you have a relationship for that takes, that could be empty. That means there's no one currently associated in that relationship. So that empty means that you have a relationship R, but nobody is taking part in that. Good question. Any other questions? Yes?
Please explain one more time why C is not the right answer.
C is not the right answer.
Because it's not a full answer.
Well, I have this arrow here, right? This arrow means whenever I know B, B determines C. Right? So B points to C because it knows what it is. So B2 should only have one value from C being associated to it. Any other questions? Question?
I'm just kind of, I'm not too sure about the arrows. Is it possible, like, is there a difference between the arrows pointing from B to S, or can you have an arrow pointing from S to C?
Can you have an arrow from S to C from the relationship to entity? No.
Okay.
So the arrow would be going from the entity towards a relationship and not the other way around. Any other questions? One thing to note is that this arrow, what it means is that each value, each object in A could at most have one value in B. It doesn't say that it has to participate. Right? So currently what we have here, this says that each movie can at most have one director. It's not saying that it should have a director. It's saying as long as it has a director, it needs to be only one. But what if we want to say every movie needs to have a director? So we need to have a new kind of constraint, which is participation constraint. And participation could either be total or it could be partial. And it could be the case that I want everybody to participate in a relationship. Every movie has to have a director. I'm not going to allow a movie in my database that does not have a director. So let's have a look at this example. And let's see what this example is saying. So we have movie people and we have movies. If you have a thick line, that thick line is indicating full participation. Okay, so if I have movies and I have a thick line going towards direct, that means that every movie has to have a director. So every movie has to have a director. It also has an arrow, which means that it needs at most one director. So a thick arrow would mean exactly one director per movie. To be considered a movie people, you need to have participated at least in one movie. And to be a movie, you need to have at least one person having participated in your movie. So you wouldn't be a movie people if you haven't ever worked in a movie, and you wouldn't be a movie if no one's working on your movie. Does that make sense? So let me just say that again. You'll be considered a movie people only if there's been a movie that you worked on. So I'm not considered a movie people because I haven't worked on any movies. And a movie will be considered a movie only if it has people working on it. If it's just a movie without anyone working on it, it's not really a movie. And every movie needs to have one director because it's a thick arrow line going towards the relationship areas. Question?
So if you're a director and you directed some movie, then are you considered to have worked on that movie? And if yes, then what's the role? Is it director or?
Can you repeat that?
Like if you are a director and you directed a movie, then are you considered to also have worked on the movie?
Right. So the question is, if you have directed a movie, does that mean you have worked on the movie? Right?
Yeah.
So that question depends on how you are going to design this database. It could be the case that work on is going to be any kind of work that you've done on the movie, whether you've acted, whether you've directed, whether you've been a producer, it's all considered there. It's all considered working on a movie. And then they'll have another relationship where more specifically tells you whether what you've been doing. And this one tells you whether you've been a director. So if you've been a director, you will be added in a work on relationship. Question?
Yeah. So for a database like this, would you still be able to add a movie without adding the director to the movie people database?
So the question is, would I be able to add a movie if I don't have a director for it?
Yeah.
The answer is no. So this is the reason why we have this in place is that, look, if you want to give me a movie, you need to tell me who the director is. So this will not allow you to add someone a movie if you don't have a director for it. And this is something that we're coming up as the designer for the movie. It could be relaxed off if you don't always have a director. But if you want to check for integrity, it's something that you might want to consider having it. Question?
So like as a follow-up to the question I just asked, so directs would be kind of like a subset of worked on or
Right.
something like that. So that would be like another constraint because you can't have directed the movie without having worked on it.
So direct might be a subset of work on, and you're right. Is this a good design? Probably not because you have redundancy in it. But it shows that direct is a constraint that you need exactly one value and work on as full participation. But it's not a good design because it might introduce redundancy. And we'll actually talk about this later and how we can remove that redundancy. Question?
You're saying redundancy is a bad thing.
We'll try to avoid it as much as possible because the thing that was mentioned before is that if you have multiple ways of saying the same thing, it's always hard to keep it consistent because you might change it somewhere and not in another place. What's it?
What is a partial participation example in this table?
Can I get your name as well?
Shirley.
Shirley? So the question is, what's a partial participation here, right? Partial participation would be from movie people to directing. So only part of people that are movie people will be directors. The rest are other people. Anything we've seen so far, which is just a normal thin line, is partial participation. Any other questions? Okay, now let's see why participation constraint is important. It's important because I need to have the database that I have and I want it to make sense. Let's just switch back to our UBC example for a second. Let's say I have a table which stores your information as a student, and let's say I have another table which stores information about your grades. Now, would it make sense for me to store grades for a student that doesn't exist? Right? So that, in order for that grade to make sense, I'm going to say, look, there needs to be a person that is associated with this grade. And if you want to delete that student, I'm going to tell you, well, what am I going to do with this grade now? Because it wouldn't make sense for me to have this grade if there's no student associated to it. Now the same will go here. Let's say these are the rules of my tables here. Would I be able to delete James Cameron without deleting Avatar? And the integrity of this database is going to say no. You cannot delete this person because that movie needs a director. If you want to delete this guy, give me a name of another director and I'll put it in. What about this one? Would I be able to delete Avatar without deleting James Cameron?
No, you wouldn't, because there are a bunch of other people who are still working on that movie and it's still attributed to that movie, right?
So Mike's saying I cannot remove James Cameron because there's still Avatar, because I still have a bunch of people that are working on Avatar that have a constraint with that. That's one reason why I cannot delete it. The other reason, based on what I see here, is that every movie people has to have worked on some movie. If Avatar is the only movie that James Cameron has worked on, if I remove it, that means that he hasn't worked on a movie before. Therefore, he's not a movie person anymore, and I need to remove him from that list as well. And this is one of the main rules of your DBMS. DBMS, once you give it some rules, it's responsible for making sure that all the rules that you're mentioning are being applied to the data set that you have. Any questions? Okay, so here's some more information about line types. If you have a thin line, it's just a many-to-many relationship without any constraint on participation. If you have an arrow, that means the other side has cardinality of 1. And if you have a thick line, that means that it requires total participation and can be added to any line or arrow. Right, one more clicker question. Please do it on your own again, first. On your own, please. Alright, let's finish the first round in 5, 4, 3, 2, 1, and the clicking. Right, so 25% of you are wrong. Discuss it with your neighbors and try convincing them you got the right answer.
like this.
Science, law, and physics. Science, law, and physics. How do you get
You're done?
Wait, so you just said about
Good job. Okay, so most of you got this one right. A and B are not correct because C must participate. So C needs to participate, and C has both values C1 and C2. So you need to have both C1 and C2 in S. You don't have them here. A determines B. So here you can't have A1 and B1. A1 having association with both B1 and B2. D, however, is the right answer because C is fully participating and there's no restriction on the constraint on the other side. Any questions?
So a full participation means like all the entities in the entity sets must participate.
In at least one value from the other side. Right? So C1 and C2 are the objects in our entity C, and they have at least one relationship with something in B. Could have more, but at least one. Any other questions? Okay, so if you thought we were out of pretty things, we also have the triangle to talk about. We've had oval, we've had rectangles, we had diamond for relationships. Triangle is going to show is a, or it's going to show you generalization or inheritance. So similar to Java or other programming languages, we can have one entity and we can inherit from that entity. So we have movie people, and we can inherit from that movie people to have actors or musicians. So you can be an actor, which is a movie people, or you can be a musician playing on a music for a movie, but you're also considered a movie people. The reason for using ISA or inheritance is for you to be able to have descriptive attributes that might make sense for a subclass of people in an entity, but not other people. For example, it might make sense for actors to have an agent name, but it might not really make sense for musicians to have an agent name or for actors to have an instrument. Now, this is something that usually a lot of people confuse, is that how is an ISA different from a relationship? Right? Because you can think of this as movie people, this is a relationship ISA, and actor is the other entity. And one of the main things that one of the main differences is that when you have a relationship, both your entities are strong entities themselves. That means each of your entities on their own have a key and they are distinguishable and you can identify them. But in inheritance, if my actors has only one attribute, which is agent name, there's no way for me to distinguish each actor just with the attribute that it has, but rather I would also need the rest of the attributes for actors, hence ID, name, and date of birth, in order to distinguish that person. Okay, so this is how this is different from having a relationship which specifies the relationship between movie people and actors. Question?
Okay, so movie people can be actors or musicians. Can musicians be actors or movie people?
That's a great question. So the question is, can you be both at the same time, I guess? Is that, can you be an actor and a musician at the same time?
I guess so, yeah.
Right?
Or can a musician, like, movie people and then...
Movie people is superclass.
Yeah.
So that's on top.
Okay.
You're a movie person if you're an actor,
Okay.
if you're a musician, if you're a director, if you're whatever. All of these are movie people. So that's the superclass. And now you can be one of the following. You could be an actor, you could be a musician, you could be a few of them at the same time. Question?
Does that superclass have to come out of the top of the triangle then?
Your name?
Anna.
Anna. So Anna's asking, does the superclass have to come from the top of the triangle? And the answer is yes. So please always have your triangle similar to this one with the superclass on top. Okay, so don't turn the triangle around and have the superclass in the bottom. Don't have it sideways. It's just confusing for the TAs and I when we're marking it. Always have it in the same format. Thanks for the question.
Do you have multiple inheritance?
Can you have multiple inheritance? Great question. And the answer is depends on which ER model that you're using. One of the problems that comes up when you have multiple inheritance is the key. Where would you get the key from? Is the key coming from this side? Is it coming from this side? The ER diagrams that we're covering in the textbook does not allow you to have multiple inheritance. And we're not going to discuss it in this class either. But there are methods in ER that allow you to have that. Other questions? Weak entities. So up to now we've seen strong entities. Let's see what weak entities are. A weak entity can be identified uniquely only by considering the primary key of another entity. So let's say I have my movie people, which are strong entities, and these people are insuring some of their dependents. Okay, so it could be spouse, it could be children, it could be someone that they are insuring. Now, for these dependent people, we don't really care about them. And the only reason why we have them in our database is because they are related to some of our movie people. Hence, we're not really keeping much information about those dependents. We have their name and we have their age and that's it. Since we don't really have much information about this, or many use for them on their own, we're making them dependent on our movie people. What it means is that for a dependent to be considered in this database, they need to be related to a movie person. And again, the key which is going to come for a dependent is going to be a combination of something that they have and the key for the movie people. So a weak entity is going to be shown with a thick rectangle and a thick diamond. With weak entities, you always need to have full participation. I cannot have a dependent in this database who's not related to anyone from my movie people. Weak entity also needs to be one-to-many. So a dependent cannot have dependency or be insured by multiple movie people in my database. Okay, so that, again, I have the arrow pointing towards the movie people. That means whenever I know the dependent, I would know who the movie person related to that dependent is. And again, weak entity sets are shown with a thick rectangle, thick line, and a thick diamond. Any questions about what a weak entity is? Question at the back.
Why is P name bold dash underline?
Can I get your name?
Norman.
Norman?
Yeah.
So the question is, why is this dashed on the line? And the reason is, it's a key but not really a key. Right? So P name is going to be part of a key, but I can't guarantee that all my dependents have different names. So that P name combined with the ID together are going to be my key for this weak entity dependence. That's why it's dashed lines, because it's not really a key, but it's part of it. Question?
But then couldn't you have two dependents with the same P name and related to the same movie person?
Not here. So in my current design, I cannot have two dependents for the same person with the same name. That's good to think about that, because assuming that could happen in my database, I need to come up with a way to resolve that problem. Any other questions? Right, let's do this one on your own first, please. No, since most of you are wrong, let's discuss it with your neighbors.
I was just like using common
You don't know. Yeah. Oh, but so it's not
Right, 5 more seconds.
I don't know.
Okay, so it seems like it's either D or E, but which one? Before I go on, I forgot to introduce Takaro, one of the great TAs for the course. He'll be coming to the lectures with me and helping you guys. So if you guys had any questions, just raise your hand and either of us will come and help you guys. Okay, so let's see.